Okay, we're gonna work out a video on how to do p-values and test statistics, and here it is. Okay, the problem says, suppose that one of your friends who is not an industrial engineer wants to be a candidate for the SGA president election next year. She knows that you've obtained practical knowledge in your Stats 2 class. She asks you to help her decide whether she should invest the time, money, and effort required to run for the president. She commissions a poll and decides that if more than 10% of the electorate would be willing to support her, she will launch her campaign. The poll asks 1,000 potential voters about their opinion. Around 75 of them respond that they would support the candidate. The level of significance is 5%. So to set up our test, we're going to need to define a couple of things. The first thing are our hypotheses. So we have a null and an alternative hypothesis. For this case, we're going to define our null hypothesis to be that the probability is equal to 10%. And then an alternative hypothesis is going to be that the p is greater than 10%, which means she should launch her campaign. A couple of other things we need for this problem is our sample size, which is 1,000. Our y value in this case is going to be 75, since we said 75 of them responded. And then we said since our level of significance is 5%, our alpha is going to be equal to 0.05. From here, we're going to define our p hat, which is y over n, which is equal to 75 over 1,000. We're also going to define our standard deviation, which is equal to the square root of our probability times 1 minus the probability over our sample size. So that's going to be 0.1 times 1 minus 0.1 is 0.9 divided by 1,000, which is going to be equal to 0.00948. We put that in a calculator. From there, we can get our z value from all of these values we've already gotten, which is going to be p hat minus p naught over standard deviation, which is going to be 0.075 minus 0.1 divided by 0.00948. And from there we get negative 2.637. So to perform the test using the p-value, we're going to find the probability that z is less than negative 2.64. Since our z-table only gives us positive values, we're going to need to swap that and say z is greater than 2.64, which also we will need to convert to say 1 minus p of z is less than 2.64. Reading that off of a table gives us a value of 0.0041, which is 0.9959. Now is when we analyze this p-value. So our p-value is 9959, which is greater than 0.05. So we fail to reject our null hypothesis. This means she should not launch her campaign. Okay. From here, for the 95% confidence interval, we use an equation given, and that means that our confidence interval is going to be equal to p hat plus or minus our z value of alpha divided by 2 of the square root of p times 1 minus p over n. So this is equal to 0.075 plus or minus 1.96. We get 1.96 because this is a 95% confidence interval gives 0.05. So we divide that by 2, which gives us 0.025. Okay, so times the square root of 0.9 times 0.1 divided by 1,000. Plugging this into the calculator gives us an interval of 0.0587 to 0.0913. Okay, now for the last part, we're going to be solving it if there's a 99% confidence interval. So that means our alpha is going to be 0.01 When we do this, we're concerned with our margin of error. So the equation for that is that margin of error equals z of alpha divided by 2 times the standard deviation. And so for this, we're going to plug in, according to our z table, a value of 2.576 times 0.00948, which we found way up here in part A. And we get a margin of error of 0.0244. And this means that our margin of error will increase by 0.0244. And that makes sense because the more precise you try to be, the more room for error you'll have. And that's it.